Hi everyone, in this video we'll be continuing on with the SageMaker Inference hosting series, and we'll specifically get into what everyone's talking about nowadays, which is generative AI and LLM hosting in specific. And before we even get to the SageMaker part, as always, I want to just have some theory or some understanding in terms of where exactly is LLM hosting different than the traditional ML models that we worked with so far? What are some of the challenges and nuances with LLM hosting that we really have to think about and consider? And once we get a bit of an understanding there, what we'll do is we'll talk about the different points of contact in terms of how you can deploy an LLM on SageMaker real-time inference. Number one is a model server driven approach, and we'll talk about some of the popular LLM serving engines that exist out there and how SageMaker kind of makes it easy to work with these, or if there's a serving engine that you want to bring yourself, how you can do that on SageMaker itself. And then the second sub bullet you see here, we've had some previous videos on this, and I'll link them down below, is SageMaker Jumpstart, which is a higher level API driven approach in terms of deploying LLMs. And we'll talk about these two options. We won't get hands on in this video itself, but what we'll do is we'll follow up with code alongs and kind of just sessions there in terms of how exactly we can apply some of the things that we're talking about here. So stay tuned for that in regards to those concepts in specific. And what I'll do now is I'll hop into the whiteboard as always, and before we even talk about the different options that exist, just a few quick minutes on what are the different hosting options, or sorry, what are the different challenges that come specifically with hosting LLMs. And the immediate thing that jumps to mind, right, at least for myself, is the size of LLMs are incredibly large compared to traditional ML models. And we're talking about hundreds of gigs for some of these larger models. And if you go to Hugging Face, right, as we've explored before, you'll see for some of these OSS or open source LLMs such as Llama, if you add up all the model file sizes and of the model data, model metadata that they have there, you'll see that these amount to huge models that we're working with. And the reason this is so important is this is very computationally expensive from the perspective of the hardware that we need behind the endpoint. For the scikit-learn model, for example, that we've been working with for the majority of the series, we were able to just use a CPU-based instance because the model could fit into the memory of that machine that we were working with. But when we're talking about LLMs, we're really talking about multi-GPU machines that really have the compute and juice available for us to be able for us to even be able to house these models. And the second challenge is, right, it's not just the size of the LLM itself that contributes to the compute requirements here. Another key part we need to understand is that the generation or inference for LLMs is very different than traditional ML models. And what I mean by this, and we'll take a few examples, right? If you look at a traditional linear regression model, and we'll simplify this a little here. You can imagine there's an input X and you have an output Y. So there's a direct input and output that you map to. But for LLMs, keep in mind, we're generating multiple tokens. This is token-based inference that we're talking about. And to visualize this, right, let's say we ask ChatGPT or whatever other LLM that we might be working with, let's say, who's the greatest tennis player ever? And the LLM generates the greatest tennis player ever is Roger Federer, or it should do that at least. He is the real GOAT, and I will argue that forever. But back to the point, let's say like we're talking about it, right? When it outputs that statement, it's generating tokens at a time. And this is regardless of whether you're using streaming or not. With streaming, you can see it generates tokens in live as it's outputting, as it's giving you the output for the question or input prompt that you get. And even in the case that you've just disabled streaming and you just want to output back, in the back end with an LLM, and obviously every LLM has its own specific way of dealing with tokens or what it defines as a token, there's tokens that are being generated at a time. So let's say the output is the greatest tennis player is RF. The key thing for the LLM, though, is as it's generating these next tokens, it needs to retain the previously generated tokens and their attention score or calculation to be able to generate an appropriate next token that makes sense. And the main thing that we don't want to do is we don't want to regenerate all of those previous tokens each and every single time. So if I'm at the step where I'm generating tennis, I don't want to have to regenerate the greatest and do whatever other calculations I need to there. Um, Again, if I've already generated these, I need a way to store these previously generated vectors or attention scores and like kind of like what we're capturing there in memory, so that I can retain this and efficiently continue generating whatever tokens are next. And that's where the concept of something known as the KV cache, this stands for key value cache, is very, very important and adds to computational requirements because we essentially need a place to store the previously generated tokens and their attention calculations or kind of representation, in terms of what we're dealing with there for the vector. And this is so, so crucial, right? Because this also adds, because we need space within the machine to be able to store these. So an LLM, when you're hosting it, it's not just the size of the LLM itself. You also need to factor in factors such as this KV cache, right? Which becomes really, really crucial, especially when we'll eventually talk about inference optimization and different kind of optimization strategies that we can apply to improve LLM inference. But we need to take into consideration both the size of the LLM and factor in the KV cache, um, kind of feature, right? In terms of what we need from a computational perspective for the hardware that we need behind the endpoint. So these are just two of the many differences, but two of the large ones that you should really think of or be aware of before coming to the right decision in terms of how you want to host your LLM. And these might not even matter. You might not even want to think of these, and there's options for that, as we'll talk of in terms of what you can use on SageMaker itself. But these are just some features that I think is good for anyone to really be aware of, at least at a high level, in terms of what's happening behind the scenes when we get to LLM inference in specific. With that being said, right, on SageMaker itself, there's three different approaches that I wanted to introduce today, and it's by no means a comprehensive one. There's different ways that you can work around, but these are three of the most common ones I see that meet most people's use cases. Let's say that want to have, you do have a preference in terms of your LLM model server or the serving engine that you're using, and you have knowledge in terms of the serving stack, just like we talked about previously in terms of different model servers such as Trident, short serve, DJL, whatever it is, right? Let's say you have some knowledge of the different serving stacks or containers that exist within SageMaker, then you can go to option one. And this is when you want to pick the serving engine slash container. And for this, there's some popular ones that are already supported natively by the available SageMaker managed images that we always revisit or talk about. And one of those is the LMI container, the large model inference container. And the next video will be specifically around this and the different features that are available within it. And we'll get hands on there too. But within the LMI container, different popular model serving engines for LLM specifically, such as VLLM and NVIDIA TensorRT LLM, are supported as backends there. So if you know these different LLM serving stacks and you know certain kind of optimization, such as server-side batching, or any kind of quantization that you want to do through these serving stacks itself, you can take the managed AWS image or container for LMI and pick the specific backend that you're working with and have that as the container image that we always talk about. The container image and the serving stack are essentially the same thing there. And you can select the LMI container and it'll link the exact images that are available for it within AWS as well for you. The second managed container, right, and this is also pretty popular in the LLM world right now, is text generation inference. And this is provided by Hugging Face. So if you're more familiar with this serving stack in particular, or you want to use this, you can go the Hugging Face route. Optionally, right, you can also load test these different kind of engines, these different serving layers, and see what really fits your use case. Because some might be more tailored for use cases such as summarization, some might be more tailored for Q&A. So really depending on your LLM inference use case or your kind of team or your own familiarity with these different serving engines and layers, you can make an informed decision on which model server do I want to use. And in specific, these two are supported natively by SageMaker managed images or deep learning containers. So you could go that route. Optionally, right, I'm actually going to jump to three before I even go to two. Let's say that there's a server that's not yet supported as a AWS managed container, such as SGLang. You can bring your own container to SageMaker, where you expose the necessary port which is 8080, I believe, for SageMaker Inference, and the Dash Invocations path. And you can essentially build that container and bring it and integrate it with the SageMaker real-time endpoint. And I'll link the BYOC kind of approach or document in the resources beneath as well. But yeah, you're not constricted to any model server per se. So if you have more advanced knowledge in terms of what you would like to use here, you could go that route too. But really, what I've seen is a lot of people are very comfortable with LMI or TGI in terms of what you would like to use, and it's pretty easy to get started with both, as we'll explore later on. And now, right, let's just say like I just want my LLM hosted. I don't want to think about a model server. I don't want to think about a container. I definitely don't want to play with Docker. I don't really want to think about any of the parameters that I might have to set, such as batch size or any kind of tensor parallel, any optimizations I might need to think of. I don't really want to work with. Then you can go the API driven route. And this is the easiest to get started with, because what will happen is you'll simply specify your LLM, let's say Llama, and what will happen is within Jumpstart, there's predefined compute and container options chosen for you. So there's existing kind of benchmarks that have already happened in terms of which serving engine is best here. What is the compute type that I need to be able to host a model of this size, right? So if you really don't want to deal with any of those lower level details, you can go the Jumpstart route. There's still going to, it's not serverless, just to clarify, there's still going to be compute behind it, but it's pre-chosen for you depending on the LLM that you pick from it. So it's really a model zoo, very similar to kind of Hugging Face with different OSS models and LLMs across all this. But yeah, at a high level, these are the different options that you can think of, and these are different ways to really tackle these challenges that we talked about here. And specifically in these coming videos, what we'll do is we'll explore deploying via the LMI container. We'll explore deploying via the TGI container. I'm going to give you the code around both of those. And we'll talk about maybe some of the optimizations you can do to really enhance LLM inference in terms of latency and throughput, and how that can be a little different, especially, right? Because as we can imagine, these models are not going to be generating as many requests per second as a tiny scikit-learn model as we worked with so far, but we'll see how we can really improve performance there. With that being said, right, what I did want to do is really quickly hop into, let me get out of this slide deck right here, really quickly hop into the console itself and show you where you could get started if you want to before the next video itself comes. You can go to Jumpstart here or within Studio, and you'll see that there's different publicly available models from different model providers. So just DeepSeek, Hugging Face, Meta, here in Jumpstart within the Studio UI. And you can directly deploy any of these models. So if I want to deploy the DeepSeek model and I clicked one of these, you can deploy, and there's also training and evaluation enabled for a few, but you can directly deploy these two SageMaker endpoints via the UI or the SDK. So like I said, this is a very easy or quick way of getting started with LLM hosting itself. Now, specifically, right, for LMI and TGI, if you want to go that route, if you go to these available images, you'll notice if I type in LMI, I believe, the different large model inference containers that exist, and I will also link the documentation for you in a one singular source or page for you to reference all of this from this video. But you'll see the different large model inference containers that exist with the different serving engines, such as VLLM or TensorRT LLM. LMI dist, if you see here, we'll talk about it more in specific, is a kind of nuanced or kind of built upon version of VLM from my understanding. And then you can also see the different text generation inference containers that exist here within SageMaker. So these are the managed images of these different models serving engines. And what I've done is I've put together a little Notion page here, just a public site for you guys to all reference, for all of you to reference in terms of the different kind of use cases here. So you can take a look at this diagram that we kind of pre-drew out here in terms of what are the different options, when to use what. And what I've also done is linked kind of videos and also different documentations and kind of code samples for each of these different options. And like I said, if one of them doesn't make sense or you don't know how to get started with any of it, we will get really directly hands-on with them in the coming months. That should be out this week as well. So what I'll do is I'll release the code samples. If you want to get started ahead of time, you can reference these here as well and kind of get a head start there. But yeah, I think that's mainly what I had for today. I'll link this Notion page down below with other resources. If you have any questions or any doubts or any feedback, as always, please feel free to leave it down in the comments section. I hope today was a good like theoretical understanding in terms of LLM hosting and some of the different ways you can get started with it in terms of SageMaker itself. So as always, thank you for watching. If you enjoyed the video, feel free to leave a like and subscribe. Thank you, and I will see all of you very, very shortly. Thank you.